Okay, Assalamualaikum warahmatullahi wabarakatuh to Dr. Azizan. So we are from Group 4, are going to present our temperature sensor, which is a thermistor. So next slide. So for the introduction part, the term thermistor comes from the words thermal and resistor. Thermistor is a type of resistor whose resistance is reliant on temperature, which means its resistance depends on temperature. So thermistor is usually made from metallic oxide, which is molded into big disc or cylindrical shape and then will be enclosed by epoxy or glass. So the purpose of thermistor is to establish a temperature measurement. The measured value of thermistor electrical resistance can be correlated to the temperature of the environment in which the thermistor is being placed. So next slide. So, thermistor can be divided into two, which is NTC and PTC. NTC means negative temperature coefficient, while PTC is positive temperature coefficient. So, for NTC, temperature inversely proportional with resistance, which means when the temperature is decreased, the resistance will be increased. For PTC, temperature directly proportional with resistance, which means when temperature is increased, the resistance also will be increased. For the temperature range is for the NTC, negative 50 degrees Celsius to 200 degrees Celsius. For PTC, 60 degrees Celsius to 120 degrees Celsius. NTC is used for temperature sensing application, oven, air conditioning, and fire detector. And PCC is used as fuse and heater. And at below here, we can see about its symbol and NTC and PTC. Next.
So the working principle of thermistor, firstly, the temperature of thermistor body affect how resistant it is. The resistance of thermistor does not change linearly as temperature change. The resistance temperature curve of the thermistor is non-linear. To measure the thermistor, we use the resistance meter. And then about NTC thermistor, temperature increase when resistance decrease. And then for PTC thermistor, the temperature increase, the resistance will increase too. Then the temperature can be determined by measuring the resistance of thermistor at a specific temperature by understanding the precise relationship between the change in resistance with temperature. And then the type of material used to construct the thermistor affect how the resistance change with temperature. And now we have NTC. NTC is used, the material is semiconductor, and then the PTC is conductor. Next.
So next for temperature range and accuracy. So as you all know that sensors are available with variety of base resistance and resistance, and actually is the temperature which influence the resistance itself. So for the low temperature application, which is the negative 50 to 70 Celsius, we use a lower resistor, which is 2252 to 10,000 ohm. And for the high temperature, we will use the high resistor, which is above 10,000 ohm. So the accuracy of thermistor is approximately plus minus 0.2 Celsius within the specified temperature range. And as we know that their thermistor will be equipped with either epoxy or glass. So for the epoxy coating, it will be used for a lower temperature, which is negative 50 to 150 Celsius. And for the glass coating, we will use it at the high temperature, which is 50 to 300 Celsius. Okay, next.
So next is the applications of the thermistor. So firstly, the thermistor temperature is used in household appliances to measure the temperature. So the appliances such as microwaves and refrigerators rely on the thermistors for proper temperature control. Next, digital thermostat are also one of the device that use these thermistors. And thirdly, The thermistors are also used to monitor the temperature of battery packs while charging, as modern batteries such as lithium-ion batteries are very sensitive to overcharging. Hence, the temperature will provide a very good indication of the charging state and when to terminate the charge cycle. So next, I guess that's all from our group. Thank you.